Alright guys, so today we're taking a look at another differential equation. So how can we tell this is a differential equation? Well, we have h prime on this side, h on that side. Typically if it was like h prime of x equals x squared plus 2x, and everything's in terms of x on the right side, we wouldn't have to go through the process of the separation of variables. But here we have h prime and here we have h. So what we're going to have to do is do a separation of variables to solve this one. So let's go ahead and change the way this looks. H prime we could rewrite as dh dx. And we'll put 6 times h. A little bit easier to look at. So what I'm going to go ahead and do is divide the h to the other side. So we'll have 1 over h dh, multiply the dx to the other side. So we have 6 dx. Now it's time to integrate both sides. And, oops, it's supposed to say dx. And so we're going to have the integral of 1 over h is natural log of h equals 6x plus c. You really could plug in your initial condition at any time, but this would be the best time. It's usually the easiest. So initial condition, we have that h of 1 is 5. And what this means is that when x is 1, h is 5. So when our input is 1, our output is 5. So let's go ahead and plug that in. So what we're going to have is the natural log of 5 equals 6 times 1 plus c. And I like this example because there is technically a natural log of 5, but you have to use a calculator. You're going to get a bunch of long decimal answer. So we're just going to leave it in this way that we just have natural log of 5. And you'll see how it works out in the end. It actually works out kind of nice. So I'm going to go ahead and subtract the 6 to the other side so that we get that c is natural log of 5 minus 6. And I'm using those parentheses really just to show you that only the 5's on the inside, and we can't subtract the 5 and the 6 right now. So let's go ahead and substitute this back into our c right here. So I'm going to take this part right there, substitute it in, and we'll finish solving for h. So we have natural log of h equals 6x plus the natural log of 5 minus 6. And in order to get h by itself, we're going to go ahead and raise each side with a base of e. So each side becomes the exponent for the exponential function, but the whole purpose of that is because e and natural log right here, they're going to go ahead and cancel out, leaving us with h equals e to the, and I'll use parentheses just to show you everything's up here, 6x plus natural log of 5 minus 6. Now earlier I promised this natural log of 5 is going to work out kind of nicely, and sometimes these things don't work out nicely, but they're fairly simple. So we could separate this all. If this was a free response question, you're done, but we could separate these all. If it's multiple choice, they might do this. So we'll have e to the 6x times e to the natural log of 5 times e to the negative 6. And the reason we can do this is because when you multiply numbers with the same base, you can add the exponent. So it's just really taking that property and going backwards with it. So from there, we're going to have e to the negative 6. It's a negative exponent, so you can see that negative exponent is going to go on to the bottom. But e to the natural log of 5. Remember how earlier e to the natural log of h, e and natural log canceled out, just leaving us with h? Well, here, e to the natural log of 5, e and natural log will cancel out, leaving us with just a 5 times e to the 6x, and then the e to the negative 6 will just go to the bottom. And that's your solution.